Hey again, it's Mr. Alexander, and I'm continuing on with this Unit 2 test review, currently on question number 20, which says, solve this system right here, 2x minus 2y minus 3z equals negative 6, negative 2x minus y minus 3z equals negative 9, and negative x minus z equals negative 1. All three of these are already in standard form, which is an indication to me that we need to put it into a matrix and use the calculator to solve this thing. So the number in front of the x is a 2, in front of the y is a negative 2, in front of the z is a negative 3, and after the equal sign the constant's a negative 6. Next equation will be a negative 2 in front of the x, a negative 1 in front of the y, a negative 3 in front of the z, and a negative 9 after the equal sign. And the last equation is a negative 1 in front of the x, a 0 in front of the y, a negative 1 in front of the z, and a negative 1 after the equal sign. So after I've written my augmented matrix, I'm going to go to my calculator, I'm going to go to second matrix, over to edit, and I'm going to type in to matrix A. It's a 3 by 4 matrix, 3 rows and 4 columns, and I'm just going to type in exactly what I wrote down on the paper. Negative 2, negative 1, negative 3, negative 9, negative 1, 0, negative 1, and finally negative 1. And at this point we want to quit out, second quit, go back to the matrix screen, over to math, up to B, second matrix, enter on A, and I've got this nice identity matrix right here, which means I have a solution. X equals 7, y equals 13, z equals negative 6. I'm going to write that as a coordinate point. And that's the answer to number 20. The process for number 21 is exactly the same thing, just with different numbers. So we'll start with the matrix, the augmented matrix. And I'm going to write my equations to negative 2, negative 2, negative 2, negative 2, 1, 2, negative 4, negative 1, negative 1, 2, negative 7. Alright, at this point it's calculator work after I've got my augmented matrix. So I'm going to go back to the matrix screen. I'm going to edit the A matrix again, and I'm just going to type on top of it. So it's still a 3 by 4. Now it's 2, negative 2, negative 2, negative 2, negative 2, 1, 2, negative 4, negative 1, 2, negative 7. Second quit out. Second matrix math, B, second matrix A. I've got the nice identity matrix, which means I have a solution. X is 9, y is 6, z is 4. So I'm going to copy that down in coordinate point form. 9, 6, 4. That's where those three equations cross, is at that point. Alright, moving on to number 22. Alright. The revenue for a company selling electronic component units is given below. R for revenue of x equals x squared plus 50, where x is the number of electronic units. The cost for the production is given by C for cost equals, C of x equals negative 20x plus 700. Determine a reasonable amount of electronic units to sell in order to break even. Well, in business, the break-even point is the point where you're not losing any money, but you're not making any money. So essentially, it's where these cost and revenue curves cross. So what I'm going to do is I'm going to graph this thing and figure out where they cross. So this is calculator work. I'm just going to clear out what I have here. And I'm going to go to y equals, and in y1 I'm going to type in the revenue function, x squared plus 50. And in y2, I'm going to type in the cost function, negative 20x plus 700. I'm going to zoom in on the screen so that you can see it. And when I graph this thing, I may not be able to see anything at all. In fact, I can't. So what I need to do is change my window a bit. by using this window key. And I essentially need to zoom out a bit. So instead of making this x min -10, x max -10, I'm just going to guess for now and make it -100 to +100. And I'm going to change the scales to 10. So that means each little tick mark you see on the graph is worth 10 units. Now the y minimum, I can be a little more intelligent about that, because if you look at the equation here, the y-intercept of that one's 50, and if this one is 700, so I know that this thing should probably go up to 700, and we'll just go ahead and start it at -10 where it's at, and we'll make the scale a little bit different. Let's make the scale by 10, so each tick mark is worth 10 as well. So when I graph this thing, let's see if I can actually see it. I can see that parabola, and I can see where it crosses once. Now you might be inclined to say I need to zoom out so I can see where it crosses up here, because I can see it's going up there and it's going to like cross again up there. But if you think about this logically, we're talking about a business and we're trying to figure out how many parts are sold. So does it even make sense to look at this negative axis? What I should have done when I made this window is I should have just said, oh, well, I don't care about negative units because there are no negatives. Since we're talking about a business, like a business can't produce negative things. So I'm only really concerned about quadrant 1. So the only thing I'm concerned about is where it crosses right here. That's our break-even point. So if I go ahead and do second trace 5 and then hit enter 3 times, it's going to tell me the solution. X is 17.386, Y is 352.27. I'm just going to write that solution down real quick. I'm going to round it to 3 decimals. 17.386, comma 352.277. Okay, so let's think about what that means. Determine a reasonable amount of electronics to sell in order to break even. So is the things that are being sold the X or the Y? Well, if we look at the function where X is the number of electronic units, so what I'm concerned about is this number right here. So, question is, how many electronic units do they need to sell in order to break even? Well, it's not this answer, because they can't produce 0.786 of a thing. So in order to break even, they need to at least sell 18 units to break even. And if they're able to do that, then they'll have found the point where revenue equals cost and they won't be losing money. And now we found that solution, but I had to round it up because, as I said, there's no way to make 0.786 of an electronic unit. So it makes sense to round it up to the next whole number. So let's talk about 23. 2 girls, Lynn and Kat, leave their house at the same time to meet at the movie theater. Lynn lives 750 feet from the park, and Kat lives 3,000 feet from the park. K of t equals -80 t squared plus 800 t plus 3,000. And that models the path Kat walks until she reaches the movie theater. And L of t equals -30 t plus 750. That models the path Lynn walks to reach the theater. What does the X-intercept represent? What is the solution to the system of equations? So before I answer these questions, I want to go ahead and graph this thing on the calculator. And I'm going to do -80. Now your calculator does have a T button, but it happens to be the same as the X button. So I'm going to make that -80x squared plus 800x plus 3,000. And the second equation is -30x plus 750. I'm going to go ahead and graph this thing. And my window's no good. Well, actually I can see where they cross, but I still want to change this window a bit because I want to have a better idea of what's actually going on here. So it looks like my x's are fine. I could actually make that a bit smaller. I'm going to make this from 0 to 40. Let's go ahead and make it from negative 40 to 40. And I'll keep the scale at 10. That's fine. Now the y's, on this first equation, the y-intercept's 3,000. So I probably want to go up to at least 3,000. And I want to know what's going on. And I want to know what's going on underneath in the negative y's as well. So why don't we just make that negative 3,000 for now? We can change it later. I'll make the scale 300. So I've got a nice scale. All right, so go back to y equals and graph this thing. Let's see what it looks like. Okay, I can see the quadratic. And now I can see where that line crosses. Okay, so there's two solutions here. And we want to know what the x-intercepts represent. So if we think about what these things actually mean, the x-intercepts, there's three of them, one for the linear and two for the quadratics. So these equations model the path that they walk until they reach the movie theater. So what I think these x-intercepts are simply, so that would be when this side equals 0 and when L of t equals 0. So the time that it takes for their distance from the park to be 0. So essentially these x-intercepts are when they reach the park. Now what is the solution to the system of equations? I think it only makes sense for us to talk about the positive ones. So I'm going to find this solution right here. I'm going to do second trace 5, and I'm going to move my spider as close as I can to that solution, and I'm going to hit enter 3 times. And so my solution is going to be x equals 12.61 and y equals 371.82. And that's the solution. That's where these lines cross. Okay? Let's talk about number 24 next. Solve y equals x squared minus 20 and 2y plus 4x equals a negative 34. The way we want to do this is we're going to want to graph these. I can't use a matrix here because this is a quadratic, and matrices only work with linear equations. So if I'm going to graph it, I want to get this in y equals form. So I'm going to subtract the 4x. I'm going to have 2y equals negative 4x minus 34. And then I'm going to divide by 2 to get y equals negative 2x minus 17. And I'm going to graph this equation and this equation, and I simply want to know where they cross. So I'm going to go back to my calculator again, and I'm going to type in these two equations. X squared minus 20, and the second equation was negative 2x minus 17. And I'm going to graph it. And my window happens to be the same as it was just a moment ago, so I probably need to change it so that I can actually see this linear equation. The easiest way to go back to where you were is zoom 6. That's the zoom standard function. Okay, I can see the parabola. Well, now I can't really see the bottom, so I want to go to the window and change the y minimum to maybe negative 50. And let's see if I can see it now. Okay, there's the parabola. And I can clearly see that this thing crosses the parabola twice. So I have two solutions. Let's figure out what they are. Second trace 5, move my spider over, enter, enter, enter. So the first solution is negative 3, negative 11. And to get the other one, I'm going to do second trace 5, move the spider over closer to the other one, enter, enter, enter. And that's going to be x equals 1, y equals negative 19. And I'm out of time on this video, so I'll pick up on number 26, which I think is supposed to be 25. Number 25, 26, whatever you want to call it, I'll finish that one, and the rest of these problems on the last video.